Welcome to Automated Visual Software Analytics. This part is about the future of software analytics. We will have a look on how to enhance visual analytics, how to enhance predictive and prescriptive analytics, and how to enhance the data scope underlying software analytics. Let's start with enhancing visual analytics. In this field, we have two major disciplines, scientific disciplines, that contribute to the enhancement of visual analytics approaches, namely software visualization and information visualization. Of course, there are some more disciplines that typically contribute to this field, for example, computer graphics or scientific visualization in general. The goal, however, is always the same: to be specific to the characteristics and demands of software engineering and software engineering data. For that reason, key requirements, for example, include the ability to handle large hierarchical data, for example, in the case of legacy or large-scale systems. To be able to handle large temporal data, for example, if we consider or compare software versions recording the development of more than one decade. And it has to be effective regarding the human perception and recognition. Let's see some examples of future visual analytics techniques. One of them is the multiple hierarchical circular bundle view. As we have already seen, a hierarchical bundle view shows a hierarchy together with relations defined among the components of the hierarchy. In this case, it is extended towards multiple systems, so we can show their relations, like in this case of 3 different subsystems, for example, by opening these representations at certain points and having a kind of connection for relations that spread across an individual system. Potential applications include the visual redesign of hierarchies of multiple subsystems and systems, the preparation of independent systems that are to be merged, subsumed, or split or refactored in the future, and the cross-system comparison of relations among system components, responsibilities, and dependencies. Let's see another example. It's called the Voronoi tree map. It visualizes changing hierarchy data. It visualizes, of course, hierarchical data and the changes of the hierarchy, in the sense that a Voronoi map seems to be very stable if the hierarchy changes slightly. So if you compare both images, they look at least at first glance similar to each other, and they denote one system revision and a future system revision, but you see that the principal structure is kept, is maintained in both depictions. So Voronoi maps, more precisely Voronoi tree maps, offer one way to visualize large hierarchy data that changes over time. Let's see another example, a tool and technique that supports the understanding of multi-threaded interplays. Visual analytics is suited to support the comprehension of thread execution traces and their interplay. For example, we would like to find usages of blocking operations such as synchronization and I/O operations, or we would like to assess the temporal order of such operations. In this example, we have the focus area and the main view, the time dimension mapped from left to right, and the call stack that corresponds to the time. And now these operations are mapped on different threads, and these different threads are visualized and indicate certain operations that take place while executing a given thread. So this is just one approach how to handle at a very low technical level a complex interplay of different threats. This is also an example for software analytics that is located far below in the technical aspects of handling complex software systems. Let's see another example called software cities. They represent the evolution, the development history of a given software system. So it's a metaphor-based approach that allows for a layout-stable visualization of revisions. A height field is used in the visualization, in the depiction, to view an orthogonal attribute dimension, namely the creation time. So the software modules seem to be like a city, and the development history is encoded by the underlying height field. This is just one approach that aims to cope with the inherent difficult visualization of the time-based changes in a large hierarchy, such as a software system. So this is one approach that is currently under investigation. Let's see another part, how to enhance software analytics. It's concerned with the predictive and the prescriptive parts of software analytics. A key area of innovation is concerned with advanced methods for prescriptive analytics that is specific to software engineering tasks. One category of such software analytics tasks addresses the specific needs of the management level to support decision-making, to support better and faster decision-making at a high level of abstraction. So we are far away from the technical details that are relevant to a software development process. The management level is the hotspot of this direction in the development of software analytics. Another independent category of prescriptive software analytics addresses the needs of, for example, software development teams to get assistance in focusing team activity and development hotspots. Let's see some examples. One example is outlined here. This work is concerned with the question how to extend software maps towards a kind of recommendation system based on software analytics. Practically, this means how can the collection of software map themes, how can this collection be extended towards the specific needs regarding management, quality, architecture, and code. In this table on the right side, there are some needed descriptions named. For example, the management would like to have a condensed high-level information, on-demand context information, or discuss with other perspective up-to-date overview fact sheets and representation understood by all parties. Quality perspective would like to have information about the up-to-date system structure, module structure, maintainability, or investment-related issues. So this is just a starting point for categorizing the different information needs in the software domain, in the software engineering domain, regarding different stakeholders. Let's see another example. It's concerned with a more practical issue. It's the active management of key performance indicator objectives. So the goal is to define and monitor objectives related to software metrics targets, or generally targets related to key performance indicators using software maps. So we would like to define a specific goal in our project. Let's say for the next 3 months we would like to reduce the McCabe complexity of a subsystem, and we define a target range towards which our development should go. And the systems, a software map-based system, can now watch and observe whether our activities, whether the developer activities are contributing to this goal or whether there's even maybe a negative trend. So in this way, we can actively control, actively manage objectives defined by means of software map categories. For a given component or subsystem, a target range or corridor can be specified that is monitored over time. Predictive analytics helps to estimate whether the actual development activities lead to this goal based on a kind of trend analysis. It also determines and proposes appropriate measures to be taken and adopted by different stakeholders to keep the development on track. So this is a prescriptive part, for example, to reduce the McCabe complexity. It can recommend to refactor a given method or to change some aspects of the control flow. This involves a lot of empirically and heuristically determined information, but it makes it accessible right away and at the right point in time based on software maps. Let's see another example, benchmarking. This is a more abstract goal, a big goal in the future. The idea is to have a benchmarking across projects that show or have a similar nature. This similar nature can mean a similar number of developers, a similar branch or field of business, and maybe a similar system size. So one question, a simple question, might be, how good is my application regarding, for example, maintenance or maintainability compared to other applications that are similar to mine? So we relate, compare, and can even learn from the experience and dynamics of other software developer projects. This is at the moment a joint research activity with our partner Software Diagnostics. Yeah, and finally, we can enhance the data scope. The data scope considered and used by software analytics can be enhanced, especially towards two main directions, the financial data and business data. In this way, complementary aspects of software projects and their embedding in a company, in a business process in general, can be considered by software analytics tasks as well. So key idea is to include these important fields and to integrate them in a seamless way in our approach of, for example, or based on, for example, software maps. Software analytics extended by financial and business data can help to support decision making far beyond software engineering. I'll give you just a few examples. We can use it to effectively manage due diligence processes. We can use it for financial statements and for a report on technical debts. Cost and budget distribution can be controlled. Accrued liabilities inherent to software systems and their components can be determined and documented. So this usage far beyond software engineering becomes more and more relevant because software development represents a big part of most industries today. To see an example, here you see a technical debts and budget software map in the first prototype that we are working on. It extends the scope to financial aspects of software development. It takes into account developer salaries, developer time, and accrued technical debts. This way it can help and provide new related means, for example, regarding a company's accounting treatment. So this offers new possibilities for these accounting treatment stuff and parts that are really important in most businesses. Let's summarize this part about the future of software analytics. Software analytics will take a rapid innovative progress in the next years. As a key and let's call it game-changing technology, it has to broaden, of course, its capabilities and functionality in various directions. The three principal directions can be identified as follows. It's about enhancing the visual analytics tools by new visualization approaches, in particular specific to large-scale hierarchical data, large-scale temporal data, and effective human perception. It's also concerned with the direction of enhancing the predictive and prescriptive capabilities to effectively support decision-making and actionable insights for professionals by means of measurable, specified, monitored, and guided activities to the different stakeholders involved in software engineering. And another key direction of enhancement of future research includes enhancing software analytics with respect to the data scope for software analytics by including, for example, financial data and business data, so to say, bringing closely together the fields of software analytics and business intelligence. Yeah, this concludes this outlook on software analytics. Let us see some remarks at the end of this part, and it's the ultimate part of this massive open online course. Yeah, let me summarize. We hope, our team hopes, you got an overview of what software analytics is about, its strength, its principles, its techniques and tools. Yeah, we hope you got some ideas why and how to apply software analytics within your own context, your own projects, your own professional life. What is important for me and what is important to software analytics in general, that it is available for and intended for all stakeholders, ranging from managers to developers to testers, to all people involved in software engineering tasks. It can better communicate, and it helps people to better communicate what they consider to be important. And that's a big step forward to more effectiveness and transparency in the sense of a data-driven software engineering. So it offers a perfect communication medium, and it leads to more effectiveness and transparency in general. Yeah, you can expect a boost of productivity. It's hard to quantify that boost because it depends, of course, of the project size, of the nature of your project, of the kind of developers you have involved. But in general, based on our own first empirical observations of the last years, when applying software analytics in large commercial contexts, it can have an impact of about 30% and even more. So that's a very significant number. It's a first estimate. So this is what we have learned from applying software analytics in third parties projects. So we assume that this number is a very reasonable number and maybe even higher in some projects, depending on the specific situation, on the degree of quality and other aspects so far established in a project. But you can expect this significant boost in productivity. And let me say finally, a first professional all-in-one solutions. These solutions have to come up, such as from HPI's research partner Software Diagnostics Technology. what do I mean by all-in-one solutions? It's a difference whether you apply individual, for example, software metric tools, or whether you have a kind of systematic framework that not only offers data extraction capabilities, but also appropriate pre-configured software map themes. This kind of all-in-one solution is a big step towards a high practicability of software analytics. And yeah, we recommend such all-in-one solutions instead of a course collection of separate tools. So these are the final remarks of this course. I hope you enjoyed this course. I hope you learned about software analytics, about the terminology, about the principles, and you hopefully got some first experience with our use cases and tests we have offered. And I hope you can take advantage of software analytics in your own personal and professional future. Thank you very much for being a participant in this massive open online course of the Hasso-Plattner Institute.